You are listening to The Vocal Technologist. Spoken Tech for your ears.
Picture a software developer sitting at their desk. They have, a pretty routine task, just clearing out some digital clutter.
Just everyday housekeeping.
Exactly. So they open up their brand new state-of-the-art autonomous AI coding assistant, and they type out a very simple 4-word command. Clean up unused files. 4 words. They hit enter, grab a sip of coffee, and just wait.
Sound harmless enough.
Right. But within seconds, the AI agent doesn't just delete some old text documents. It deletes the company's entire production database.
Oh, man. And the worst part is, well, because of a critical infrastructure flaw where the backups mistakenly lived on the exact same server host.
Which is just a massive oversight to begin with.
Oh, entirely. But because of that, the agent saw those backup files as unused clutter too. So it wiped the backups entirely off the map. Complete catastrophic data loss, triggered by just a casual everyday instruction.
It's wild. Anyway, welcome to the deep dive. If you are listening to this, you are our resident learner. You're someone who wants to get thoroughly caught up on this incredibly fast-moving tech landscape. But, you do not want to drown in the absolute fire hose of information overload.
Because there is a lot of it right now.
So much. We have pulled together a really fascinating stack of sources for you today, a batch of developer newsletters from early May 2026. And our mission today is to unpack this chaotic collision between autonomous AI agents and our very fragile human systems.
Yeah, we are looking at a landscape where the fundamental role of the software engineer is just shifting overnight. We're going to explore how AI is forcing a massive foundational re-architecture of our digital infrastructure, the hidden costs of all this new code, and really how these models are beginning to threaten the open web itself.
It's a huge paradigm shift.
It is. My goal is to take all these scattered tech updates and connect them into a single, cohesive picture of our new, quote-unquote, agentic future.
Let's do it. I want to start right at the ground level with that database disaster. An incident involving a platform called PocketOS, because this really points to a massive cultural shift that developers are calling vibe coding.
Right, vibe coding.
Yeah, people are starting to blur the line between just casual computer use and professional engineering. Like, developers are getting so comfortable with AI outputs that they are trusting the machine's intuition over traditional formal documentation.
And what's fascinating here is the psychological shift that's occurring across the whole industry. I mean, when an AI coding tool works perfectly 9 times out of 10, we naturally drop our guard.
Sure, you get complacent.
Exactly. We start treating the software less like a naive text predictor and more like a senior colleague who inherently understands the business logic. But the reality is these agents don't actually understand the systems they are navigating. They are simply executing incredibly sophisticated pattern matching. And when you let unconstrained pattern matching loose on critical infrastructure without deterministic rules, well, you get the PocketOS disaster.
But the funny thing is, reading through the post-mortem of that event in our sources, the industry's reaction wasn't to blame the AI. Like, the prevailing takeaway was essentially, AI didn't delete your database, you did.
Oh, absolutely. The failure was entirely architectural. The developer provided a vague prompt, sure, but the system allowed a vague prompt to be fatal.
Right, it's a systems failure.
The source blames destructive public-facing APIs and just a total lack of deterministic control flow. I mean, if a single command from an unverified agent can wipe out production and backup simultaneously, that system was already a ticking time bomb.
Okay, let's unpack this. We are talking about the need for layered defense. So what does it actually look like to build a cage around these autonomous agents so they can, work without burning the building down?
Well, first, it requires stripping away broad permissions. Agents have to operate with the absolute minimum credentials necessary for the specific task at hand. No more root access for everything.
Makes sense.
Furthermore, any changes to the structure of your data, what we call schema changes, which modify the actual blueprint of a database, those must be gated behind a pull request. They have to be queued up and explicitly reviewed by a human.
No rubber stamping.
Exactly. And most importantly, any destructive command requires hard-coded human confirmation. You simply cannot automate the final yes when the stakes involve data deletion.
And creating those guardrails seems especially vital when you look at how these agents actually interact with our computers. I mean, our sources highlight this benchmark study comparing different methods AI agents use to navigate systems, and there is a massive inefficiency problem right now.
Oh, it's huge.
Right. AI agents that use computer vision, like the ones that literally look at a continuous stream of images of your web interface to figure out where the cursor should click, they are 45 times more expensive to run than agents that just use structured text-based APIs.
And that staggering cost difference comes entirely down to token consumption.
Yeah.
Feeding a live video feed or, a constant stream of high-resolution screenshots into a multimodal model requires processing tens of thousands of tokens every few seconds.
It's just chewing through compute.
Exactly. Contrast that with an API, where the agent just sends a few hundred bytes of structured text directly to the backend. It's night and day.
Relying on those vision-based agents, it feels like hiring an incredibly expensive genius-level assistant, but instead of giving them a secure login to the company database, you just make them stand behind you, stare over your shoulder at your computer monitor, and click the mouse for you. It's brilliant that they are capable of doing it, but it is wildly inefficient.
That is the perfect way to visualize it. I mean, vision-based agents are currently a necessary evil for interacting with third-party software where a company refuses to grant back-end access.
Sure.
However, for internal development, auto-generating API services so agents can talk to each other purely through text. That's really the only cost-effective path forward.
And because we have to build these complex API surfaces and strict guardrails just to safely contain the AI, the day-to-day reality of a human developer has completely mutated. The bottleneck is no longer typing out the code.
Not at all.
AI has made code generation dirt cheap. The new bottleneck is managing the absolute chaos of integrating all that generated code.
Yeah, the physical implementation used to be the hard part. Now the real work is organizational coherence. Developers are functioning way more like project managers now, constantly providing these AI agents with shared context so they don't blindly build disconnected, overlapping systems that just clash with one another.
Which perfectly sets up this incredible irony highlighted in one of the newsletters. So, a developer needed to make a minor 10-second logic fix in their application. Guess how long it took?
I know this one, but it still hurts to hear.
It took them 10 hours to complete the job. 10 hours for a 10-second fix because they weren't actually writing code. They spent the entire day fighting broken dependencies, wrestling with complex testing sandboxes, and trying to resolve hardware-specific build failures.
It's a nightmare.
Developers are just constantly fighting the massive layers of abstraction they've built to accommodate all this automation.
And we are seeing this strain across entirely different ecosystems. The sources mention developers struggling with async Rust on microcontrollers, for example.
Okay, break that down for us.
So Rust is a highly efficient language, right?
Mm.
And async allows it to handle multiple tasks seemingly at once without blocking the main program. The compiler achieves this by automatically generating these complex state machines behind the scenes.
Right.
Usually these abstractions are zero cost, meaning they don't add runtime overhead. But on a tiny microcontroller with only a few kilobytes of memory, that hidden compiler-generated code causes massive binary bloat. It literally fills up the device's storage before the program even runs.
Wow. And the sources mention a similar headache in mobile development too, right, with React Native animations?
Yeah, developers are finding their applications dropping frames and stuttering because of repetitive shadow tree commits.
Shadow tree commits.
Basically, to render a smooth animation, the framework has to constantly calculate the layout in the background. That's the shadow tree. And then commit those changes to the screen.
Okay.
When AI generates slightly inefficient animation loops, those background calculations just eat up the entire frame budget, which leads to a terrible user experience. Every time we add a layer of abstraction to make writing code faster, we make debugging the underlying infrastructure exponentially harder.
I gotta say, I find myself really questioning this overarching narrative of pure efficiency, because on one hand, we are generating code at an unprecedented scale,
True.
but developers are spending 10 hours fighting build tools, and at the exact same time, companies like Coinbase are laying off 14% of their workforce to integrate the efficiency gains provided by AI. They are flattening their corporate structure to a maximum of 5 layers, demanding that managers act as individual contributors again.
Right.
So, are we actually becoming more productive, or are we just generating a completely different flavor of high-tech busy work?
I think that skepticism is entirely justified. And one of the articles explicitly addresses this illusion of productivity by introducing a concept called output competence decoupling.
Okay, let's define that. How does output decouple from competence?
Well, historically, if an employee produced a highly polished, intricate report or a massive block of functional code, You could safely assume that person possessed a high level of underlying competence and understanding of the business, right?
Yeah, of course.
AI has severed that link. Highly agreeable AI models can generate confident, articulate, flawlessly formatted organizational material that is factually inaccurate or just strategically completely misaligned.
It makes me think of a restaurant that decides to buy a state-of-the-art robot chef. The robot can plate dishes beautifully. The presentation is Michelin star quality, but it uses plastic instead of actual food.
Exactly.
It looks perfect on the surface, but if you bite into it, it's fundamentally broken.
Precisely. You have fewer people generating massively more output, but the organization itself isn't actually learning or improving. Companies are measuring the wrong metrics. They track token usage to prove they are innovating with AI instead of capturing the informal, critical discoveries their human employees are making.
Right, that institutional knowledge.
Yes, mature human judgment, the ability to sift through the beautifully plated plastic slop, as you put it, is more critical now than at any point in the history of software.
And to support this massive volume of output, both the brilliant code and the slop, the underlying plumbing of the tech world is just being pushed past its breaking point. We are watching a forced breakneck evolution of back-end infrastructure. I mean, I keep seeing these monitoring platforms struggling to keep their servers online.
And if we connect this to the bigger picture, it reveals the massive, invisible physical costs of abstraction. When you have AI agents spinning up microservices, generating code, and querying databases thousands of times a second, traditional infrastructure simply melts down.
It just can't handle it.
Databricks had to completely re-architect their systems. They built a custom time series database called Pantheon alongside a platform called Hydra, strictly to handle 10 trillion monitoring samples a day.
10 trillion samples a day just to monitor what the systems are doing.
Mind-boggling.
That scale is dizzying. And the newsletters also mentioned Airbnb having to build entirely isolated clusters for their monitoring workloads.
Yeah, they had to implement a dead man's switch into their meta-monitoring layer.
What does that mean in this context?
Well, when infrastructure gets so complex that the system designed to watch for errors gets overwhelmed and crashes, it dies silently. No alarms go off because the alarm system itself is broken.
Oh, that's terrifying.
Right, so a dead man's switch is an isolated secondary system that does nothing but listen for a continuous heartbeat from the primary monitor. If that heartbeat stops, the switch triggers a massive alert. They had to build this just to survive the silent failures caused by AI traffic spikes.
Yeah, but expanding server capacity is only half the battle, right? The AI models themselves have to process information faster. I mean, nobody wants to sit there watching a model type out a response one word at a time when it's supposed to be writing an entire application.
No, and that is where we are seeing some brilliant software engineering workarounds. Like Google just announced a technique for their Gemma 4 model called speculative decoding. They introduced what they call drafters.
Okay, how does a drafter speed up an LLM?
Instead of having one massive AI model calculate every single token sequentially, which is a heavily intensive, slow process, they use a tiny, lightning-fast draft model to guess the next several words in a sequence.
Oh, interesting.
Then the main massive Gemma model looks at that entire drafted sentence and verifies it all at once in parallel. If the guess is right, the model skips ahead instantly. If the guess is wrong, it corrects it. It dramatically speeds up the inference time for developers without sacrificing the complex reasoning quality of the massive model.
Here's where it gets really interesting, though. Not every infrastructure problem has an elegant software fix like that. Some protocols are just fundamentally incompatible with AI. Look at OpenAI's struggle with voice agents. The sources talk about how they are hitting a wall using WebRTC.
Which is crazy because WebRTC has been the undisputed standard protocol for human video and voice calls for years.
Exactly. But it's failing the AI test. It's like, well, think about it this way. It's like we built this incredible, sprawling highway system for human video calls where it really doesn't matter if a car drops off the road here and there.
Right, our brains just fill in the gaps.
Yeah, if a human video stream drops a few packets of data over WebRTC, your screen gets a little pixelated for a second, but you still intuitively understand what the person is saying. The protocol prioritizes low latency over perfect accuracy. But voice AI needs a freight train.
That's a great way to put it.
If you lose a single boxcar of context in an audio prompt, the entire train derails. The AI completely hallucinates or loses the thread of the conversation.
And to fix that, they're having to lay entirely new tracks. They're shifting away from WebRTC to an architecture called QUIC.
Right.
QUIC handles network switching and packet delivery with much higher fidelity. It ensures the AI receives the complete context without the dropouts that human brains naturally filter out.
And because the cloud is becoming such a bottleneck with all this traffic, there is a massive developer pushback happening too. Our sources detail a huge shift toward local-first web development. Instead of relying on a central cloud server, developers are adopting tools like Squai and compiling them to WebAssembly.
Oh, WebAssembly is a total game changer here. It allows developers to take high-performance code written in languages like C or C++ and run it natively, directly inside a user's web browser.
That's wild.
Right. By compiling a database engine like SQLite to WebAssembly, you essentially turn the user's laptop or smartphone into a high-performance database node.
So instead of a web app sending a request to a server thousands of miles away and waiting for a response, it just queries the database living entirely in the device's own memory.
Exactly. It completely bypasses the server bottlenecks and the latency of querying a cloud database. The application feels instantaneously fast.
But there's a catch, right?
There's always a catch.
Yeah.
It introduces incredibly complex engineering challenges regarding conflict resolution. When that user finally connects back to the internet, their local database has to synchronize with everyone else's changes without overwriting critical data.
Oof.
Yeah.
Good luck to the devs figuring that out. But this strain isn't just a back-end problem for engineers to solve in the dark. This massive AI arms race is extracting value from the public web. It's changing how content is consumed, and it's directly threatening the ecosystem we all rely on. There was a recent meeting at the W3C, the World Wide Web Consortium, that really sounded the alarm on this.
Yeah, the open web is facing a very real existential crisis. The W3C highlighted how large language model crawlers operate. They just constantly scrape publishers' websites to feed their models, which places a massive computing strain on the publisher's servers.
Right.
And then the AI provides the summarized answers directly to users in a chat interface.
So the user gets the answer without ever actually clicking through to the original source.
Exactly. It entirely severs the traffic flow, which undermines the advertising revenue model that has funded the free internet for decades. The AI extracts the value without any fair exchange.
I mean, if the web was originally built on this mutual exchange of value, you spend time creating content, and I reward you with traffic and ad revenue, and now AI crawlers just strip mine that content without ever sending the traffic back, are we basically eating the seed corn?
Yes.
What happens when the money dries up? If publishers can't afford to pay human writers, where is the AI going to get its training data next year?
This raises an important question about the fundamental sustainability of our digital ecosystem. If the flow of novel, human-generated information stops, the models will inevitably begin training on their own synthetic outputs.
Model collapse.
Precisely. And the cultural impact of this shift is already highly visible. One of our newsletters featured an essay on how AI slop is killing online communities.
Oh, it's the output competence decoupling we talked about earlier, but weaponized against forums and social media.
Yeah, exactly.
The proliferation of low-effort, thoughtless, prompt-generated content is completely drowning out meaningful human discourse. It's exhausting for users to sift through paragraphs of robotic text just to find a genuine human opinion.
And tech companies are pushing this integration aggressively, sometimes really crossing ethical boundaries regarding user consent. One report indicates that Google Chrome is silently installing a 4GB Gemini Nano AI model on millions of user devices.
Wait, silently, no prompt asking for permission.
None. Just silently downloading a massive 4GB file directly onto your local machine in the background.
That is nuts.
It aligns with their strategy to push AI processing to the local device to save cloud costs, sure. But forcing a model that big onto a user's machine silently entirely violates the trust boundary of the browser.
Speaking of trust boundaries and downloading files, we need to take a quick second for a crucial security PSA for you, the learner, because if you operate in a Linux environment, our sources are currently recommending a strict 1-week moratorium on installing any new Linux software.
Yeah, this is serious. There have been newly discovered severe kernel vulnerabilities, combined with a highly elevated risk of supply chain attacks right now.
How is AI playing into that?
Well, when the infrastructure is moving this fast and developers are relying heavily on AI agents to auto-generate code and automatically pull in external dependencies, malicious actors are finding it incredibly easy to slip compromised code into the supply chain.
And the agents just grab it.
The automated agents just pull the poison code right into the project without a second thought. So truly, only install essential security patches until the ecosystem stabilizes.
Lock down your systems for the week, folks. Seriously.
Well, what does this all mean? We have covered a staggering amount of ground today.
We really have.
We started with the chaos of vibe coding and the Pocket OS developer who deleted a production database because the industry lacks deterministic layered defenses. We unpacked how human developers are no longer typing logic, but spending 10 hours fighting massive abstractions like async rust, binary bloat, just to integrate AI-generated code.
We explored the dizzying back-end overhauls, from Databricks processing 10 trillion samples to Google utilizing speculative decoding, and finally, we looked at how AI crawlers and on-device models are threatening the very survival of the open web.
The through line here is unavoidable. The agentic era is rewriting the rules of engagement across the board. Whether you are managing an engineering team, trying to fix a bug, or simply browsing a forum, the systems you interact with are fundamentally changing from rigid, predictable tools into complex, semi-autonomous entities, and they require entirely new methods of containment.
Which brings us to a final thought I want to leave you with. One of our sources discussed a philosophical framework called the three inverse laws of robotics. The core assertion of these laws is that society must prohibit blind trust in machine output.
Which makes sense given everything we've talked about.
Right. It dictates that the human must remain fully, legally, and morally accountable for whatever their AI agent does.
So if the agent breaks the law or deletes the database, the human takes the fall.
Exactly. So if we truly enforce that reality across the industry, what does the ultimate 10x engineer of the future actually look like? Will it be someone who never writes a single line of code, but is simply the world's most brilliant digital diplomat?
That's a fascinating way to look at it.
Will the most valuable person in the room be a liability manager, someone whose entire job is to negotiate with these incredibly fast, unpredictable machines on our behalf, trying to safely extract their value without letting them burn the building down?
It really represents a total paradigm shift. I mean, the primary human value in software engineering transitions away from creation, moves toward curation, and ultimately settles on containment.
It is definitely something to chew on the next time you open up a prompt and ask an AI to clean up your files. Thank you so much for joining us on this deep dive. Stay curious, build your guardrails, and we will catch you next time.
Spoken Tech, for your ears.